Good morning, everyone. Welcome to the 13th lecture of the CSIG-VIS International Lecture Series. I'm Long Juanjuan from Jiangnan University. It's my pleasure to host today's lecture. Today, we are honored to invite Professor Alberto Cairo from the University of Miami to give us a lecture. First of all, please allow me to briefly introduce today's speaker. Alberto Cairo is the ninth chair in visual journalism at the School of Communication of the University of Miami. He is also the director of the visualization program at UM's Institute for Data Science and Computing. Cairo is the author of several books about visualization, such as The Tools for Art and How Charts Lie. He has led visualization teams in media organizations in Spain, Brazil, and the United States, and is a regular consultant for several governmental organizations and companies, such as Google. The topic of today's lecture is visualization for the general public. You can scan the QR code in the upper right corner of the screen to join the audience WeChat group and activity Ask Questions. Cairo will provide answers during the QA session. Okay, let's welcome Professor Alberto Cairo to begin his wonderful presentation. Hello, Alberto.
Thank you. Thank you so much for the nice introduction. I hope indeed that it will be wonderful. Let's see what I can achieve. It's evening over here, right? It's morning in China, but over here it's almost 10 p.m. And I usually joke that I am a morning person, so I tend to be more awake in the mornings rather than in the evenings, but I'll do my best to do a wonderful presentation. I really appreciate your encouragement.
Okay, so, it doesn't matter.
Yeah.
Now you can share your screen, okay?
I'll begin sharing my screen, yeah. Well, first of all, let me say, I need to, it says that I cannot start sharing while the other participant is sharing. So there you go, perfect. Okay, now I can.
Yeah.
So anyway, yeah, visualization for the general public, that's what I sort of like what I specialize in. I am a journalist by training and a visual designer, and I specialize on the design of data visualizations and more broadly information graphics to be presented to the general public, usually in media publications. Although right now my career leans more towards helping scientists communicate science a little bit more effectively. So my career is focused on data visualization. Right? So we can begin just by defining what I mean by that. Data visualization is essentially the visual presentation of data, the transformation of data, usually numbers, into graphic forms such as bar graphs and line graphs and other types of graphics in order to communicate the main messages that those data contain, right? Or the messages that we want to communicate with those data. Data visualization, as probably most of you know, can also be used in multiple other ways. For example, there's a whole branch in statistics called exploratory data analysis. So visualization can be used not only to communicate to other people, but also it can be used to explore data. When we are analyzing data, we can use visualization to explore data, but that is not what I specialize in. Again, I specialize more in communication. And in the past decade or decade and a half, there has been an explosion in the use of visualization, not only in the world where I come from, the world of journalism, but in many other areas, right? For different reasons, the increasing availability of data, the increasing availability of tools to visualize that data. There has been an incredible increase in the use of visualization. And in the world that I come from, in the world of journalism, one of the reasons why this has happened, particularly in the countries that I'm most familiar with, the United States, Spain, Brazil, and other countries in Latin America, this huge increase in the use of visualization has been provoked by the fact that news organizations are observing that readers really like to see information visualized. Many of the most popular stories ever published by media publications in the United States, for example, have been data visualizations. For many years, the most popular story ever published by the New York Times was a data visualization. And this project is still among the most viewed stories ever published by the New York Times Online. It's called the dialect map. It's an interactive visualization in which you can input the way that you pronounce certain words in English or the way that you refer to certain things in English. And based on your responses, it will generate a map that it will tell you where you're probably from based on your responses in a visualization format. By the way, before I forget, you will see that many of the slides contain links to projects that I'm going to discuss. I am going to make these slides available to you during the Q&A, so you don't need to write down these URLs very quickly. I will give you all the slides, so you will be able to click on these links and then visit these projects later on. This will be an anecdote, right? But it is not. I mean, it became so popular, in fact, that it even became a book. Yeah, an entire book was published thanks to this project, to the popularity of this project. The data and the visualizations were collected into a book. So I was saying that it will be an anecdote. It will be just one example, if it were just one example, but we have many others. The most popular story ever published by El País, which is the main newspaper of my country of origin, Spain, is not a data visualization, but it's a pictorial visualization, a visual explanation of how COVID-19 spreads in closed spaces. This is by far the most widely read story ever published by El País. And the Washington Post, the most viewed story ever by the Washington Post, is also, in this case, a data visualization, also related to COVID, that explains how a pandemic spreads in a country if that country adopts measures against the pandemic, or if it just lets the virus spread freely, right? It will spread more rapidly or less rapidly depending on the measures that are taken in that country. Again, these will be anecdotes, but we have even more evidence, right? A couple of months after this piece was published by the Washington Post published a job offering. They were trying to hire more people to produce visualization. And in the job posting, they disclosed that out of the 7 most popular stories ever published by the Washington Post, 6 of them had been stories produced by the graphics department. 6 out of 7 of the most viewed stories ever published by the Washington Post. There is something in here. I usually tell my students, this is great news, because if you decide to pursue a career in data journalism, data visualization, it is very likely that you will find a job, if you are good enough, obviously, to work in places like these, right? There's a huge demand for people who are able to visualize information, who are able to design information, explain that information. Those are the great news. They are great news for me, obviously, because I teach this stuff, and that means that I will be able to keep teaching visualization in years to come. But there are also things that you will need to worry about, I think. One of the things that I worry about as a person who designs visualizations to be consumed by the general public is the perpetuations of certain myths when it comes to speaking about data visualization. I have encountered these myths in many different contexts, not only in news media, but also when working for companies, for example. A picture is worth 1,000 words. Well, that is not true, as we will see later on. It all depends on whether you can read that image correctly. The data should speak for itself. This is very common in the world of business analytics. Just show me the data. The data should speak for itself. This is very dangerous. The data never speaks for itself, again, unless that you know how to read it. The third one comes from a very famous visualization book, The Visual Display of Quantitative Information by Professor Edward Tufte. If the statistics are boring, then you've got the wrong numbers. This is also wrong. Statistics can be boring, and visualization, can sometimes be used to make statistics a little bit more appealing to people who otherwise would never look at those statistics. So we need to worry about making numbers appealing somehow. Or this is very common also in the world of visualization, right? Some books that have been written about visualization convey the idea that in order to be a designer of visualization, you need to follow a certain set of rules that are set in stone. And this is actually not true either. Visualization design can be based on reasoning, on certain principles. It can be based on what we know and what we don't know about the human perceptual system. But visualization cannot be based on rules that are set in stone. Visualization is more similar to writing. When we write, we obviously need to pay attention to grammar, to symbol, to syntax, but then what we do with that language is highly dependent on what we want to do with that language, right? And as long as it works, as long as the idea that we want to convey is actually conveyed, then whether we follow rules or not, that's completely besides the point. So let me show you a few examples of why I think that these are actually myths. Let's begin with the sort of like the first few ones. A picture is worth 1,000 words. The data should speak for itself, right? A picture is worth 1,000 words. Graphics should be sort of self-explanatory. All these ideas, I think, need to be taken with a grain of salt. And this is the best example I know about it. And it's a graphic that we get to see down here in Miami every year. Is a graphic that is put out by an organization called the National Hurricane Center down here in Miami. It's a map that shows where a hurricane may go in the following 5 days, right? It's a hurricane forecast graphic, right? Using that cone to represent where the hurricane may go in the following 5 days. Most people who see this graphic for the first time, and this is the original version of the graphic, this is what the National Hurricane Center puts out, get this map wrong, misinterpret this map completely. It's a great example of a phenomena that I like to verbalize, that I like to describe with the sentence, what you design is not what people see, which sounds kind of obvious, right? But we need to consider that as well. So what is it that people see when they see this cone? People tend to see an area under threat. So you see this storm approaching, and people tend to read this map as, if I am inside of the cone, I am in danger. If I am outside of the cone, I am not in danger. Many people read it that way. Some people, and we have good experimental evidence showing this, even interpret this cone as representing the size of the hurricane increasing. So they see this cone and they actually envision something like this, the size of the storm. But that is not what the graphic is showing. So what is it that the graphic is showing? Well, it's not obvious what the graphic is showing, right? So it needs to be explained to us. Sometimes I feel, and I will get back to this later in the presentation, I feel that sometimes we should not just visualize things, we should explain things to people. So what is it that the graphic is actually showing? I'm going to try to explain it in a simplified way. And in order to explain what the graphic is showing, I need to explain how the graphic is generated. The way that it is generated is that step number one, the National Hurricane Center and many other, forecast organizations, they create different forecast models, prediction models of where a hurricane may go. And we could envision those models as lines, right? The hurricane may go here, the hurricane may go there, may go there, may go there. And we have all those lines, each one of them representing a possible path of the storm, or better said, the center of the storm. This is super important in just 1 minute. Imagine, for example, I live down here, okay? I live in Florida, Miami, Florida, which is actually down here, right? But imagine that I live here. This is a town in an island called Key West, and I misinterpret this map. Well, I may be led to believe that I am not in danger because I am very far from the boundary of the cone, right? Well, I may not be in danger. Well, maybe I am in danger. Maybe I need to prepare for the arrival of the storm, right? So anyway, path of the storm is step number two. The National Hurricane Center comes up what they consider the most probable position of the center of the storm in the following 5 days. So they say, well, the center of the storm here is today, then later we think that it's going to be here, then here, then here, and then here. And then what they do is to surround those dots with circles of increasing size. Those circles represent the uncertainty of the forecast, right? So essentially the way to read that is to say, well, they think that this is the most probable position, perhaps, but the center of the storm could perfectly end up being here, or here, or here, or here, or here, or here, or here, with different degrees of probability, could sort of like fluctuate around inside those circles. And even outside there is actually a probability, and quite an important probability, a 1 out of 3 chance actually, that the storm may end up going outside the boundary of the cone at some point in the following day. So that's a very decent chance. And what they do is to surround the circles with a line, right? And the result is what we commonly call the cone of uncertainty. So the way to read this sort of like correctly is that if I live in Key West, if I myself lived in Key West, I look at the cone and I will still prepare for the storm. I would not evacuate the city, but I will still get, I will do the common preparation that we do now here when our storm is approaching, like getting water, putting gas in your car tank and things like that, right? Because it may end up happening that the storm may end up going in this way, in this direction. And remember that the cone is only representing the possible position of the center of the hurricane. But hurricanes are gigantic objects, right? They are like this big. So if the storm ends up going this way, living down here, I may still get impacted by the results of the storm. So visualizations can sometimes be ambiguous, difficult to read, difficult to understand. They are not readily understandable. Sometimes they need to be explained. What is going on here, right? What is going on here is that I think that for years, many people in my industry, at least in the industry of journalism and producing graphics to communicate to the general public, we have used a model of communication that is pretty much unidirectional, right? We have the designer, we have the reader, and we think that just by applying certain principles, rules, best practices in visualization, right, to the design of a graphic, immediately the reader magically will understand what is going on, just because we are using good practices in design. But this is not how actually things work. The model of graphic comprehension is a little bit more complicated than that. Whenever we design a visualization, and that means myself, means you, means everybody, what you have in your mind is what we could call a schema of how that graphic is going to work, like a mental model, right? A conceptual mental model of what it is that you want to communicate, how you are going to communicate it, the elements that you're going to use to compose your graphic and how you're going to arrange them, etc., in order to convey the meaning that you want to convey. That's all part of that conceptual model that you have in your mind, right? The challenge is that, on the other hand, you may have the reader who may arrive to the graphic with a completely different mental model of what the graphic is attempting to show. And then when there is a mismatch between the model that you're using to design the graphic and the mental model that the reader brings with herself or himself to the graphic, when that mismatch happens, misunderstanding may happen. Now, how to bridge this gap? Well, the answer will be with an explanation, right? We could explain the graphic to people in order for people to increase their graphical literacy, right? And the next time that they see that same graphic, if someone before has explained it to them, then they don't need the explanation anymore. They will already know how to read that graphic. Now, what about the other misconception, right? The statistics are boring, or there are certain rules that need to be followed, and so on and so forth, right? Or if the statistics is boring, you have the wrong numbers. Well, no, sometimes we need to create graphics that are intended perhaps not so much to communicate, but they are designed more to bring people's attention to a particular data set in order to create conversations. Visualization is not just about sometimes communicating an idea. Sometimes it's about bringing attention to important information. The best example that I have for that is actually the example that I'm using in the presentation slides of this slide deck. This graphic is commonly called the warming stripes graphic, and it was designed originally by a climate scientist called Ed Hawkins. You can read more about it clicking on that link or in this link. Remember that I'm going to share the slide deck with you later on, right? The warming stripes represents the average temperature of the world between the 1800s and the 2010s, if I'm not wrong, using different shades of color, blue and red. That means blue and red means below an average, the average of the 20th century, and red above that average. And then the bluer the color, the colder the world was on average in the past, and the redder the color becomes later, right, closer to the present, the redder the color, the higher the average temperature of the world was. Well, this graphic is arguably one of the most popular visualizations ever created. It has appeared in the cover of the Economist magazine. It has appeared in protests against climate change. People are actually printing out and bringing in posters. There was one person who printed the graphic in his Tesla car. I'm even using it for the cover of my upcoming book, the book that I'm planning to write, crossing my fingers, and publish by 2023. I put this graphic in the cover because I think that is quite illustrative of certain things that we need to think about deeply, which is that visualization for communication, okay? It's always goal-oriented. And the quality of a graphic should be measured based on how well it achieves its goals, right? So Ed Hawkins's goal with this graphic was not to design a visualization for analysis or a very accurate visualization for communication or something that conveyed all the granularity and the detail of the data so people could see the actual change. No. He wanted to design a striking image, right? Just a striking image based on the data. So people will look at it, will get interested in the data, become curious about that data. So a conversation could be started about that data. He made, therefore, the graphic look colorful and fun, because that same data could be displayed in many other ways. For example, using a line graph, right? The graphic that you have on the left-hand side is another visualization of global warming called the hockey stick chart. It represents a similar data set using a line, right? It's showing the temperature going up. Ed Hawkins decided to do it through masses of color. The question is, are readers, common people, more likely to look at the graphic on the left-hand side or to the graphic on the right-hand side? I think that the answer is obvious, right? The graphic on the right-hand side is not as accurate. It is not as detailed. It doesn't convey as much information as the graphic on the left, but it's much more striking. It gives you a punch in the face. You need to stop and look at it so a conversation can be started. I interviewed Hawkins for my new book, for my upcoming book, and I asked him several questions, and he told me, well, the reaction of the visualization community was actually half positive, half negative, because I was not following visualization rules, quotation marks in there. And I actually remember my own first reaction to this graphic, which I tried to summarize in that little illustration there. I was like, oh, wow, a visualization. It doesn't have axes. It doesn't have scales. It doesn't have any label or anything. What is going on? I don't know how to read this graphic. It doesn't follow the rules. Until I realized that it was not trying to follow the rules. It was not trying to design a visualization for analysis. Right? It was just trying to design a great picture so people will look at it. So the goals of the graphic were completely different. And the graphic was completely successful because the test is out there. It went viral. It became sort of like a very iconic image. So actually it met Ed Hawkins' goals. So even if the graphic is not sort of like conventional in some sense, it's very unconventional in its design, it's still a striking image that achieves its goals. Now, that doesn't mean, for those of you who are perhaps beginning in the world of data visualization, that learning some principles about visualization is not important. It is important, right? It's important to learn principles of visualization. It's important to learn about what our eyes and our brains can and cannot do, because those are constraints to what we can and cannot do. However, throughout the years, and as I'm growing older, I am realizing what I explained to you before. I more and more see visualization the same way that I see writing, right? Writing cannot be based on rules that are set in stone. It can be based on constraints. It can be based on reasoning, but it gives us a lot of freedom, right? So these principles of visualization that are discussed in books like mine should not be envisioned as if they were straitjackets, as limitations. They are departure points and also constraints to what we can achieve and what we cannot achieve, right? So I don't believe those myths anymore. So what about this reasoning? How, for example, people who work in news media, producing these types of graphics for news media or communication with the general public, how do we reason? How do we think about visualization? Well, we usually ask ourselves several questions, right? In order when we are designing a graphic. For example, first of all, should I visualize my data at all? Because sometimes we don't need a visualization when we want to communicate something about a data set, right? So in order to answer this question, do I need to visualize my data at all? We need to remember first what visualization is for. What is actually the purpose of a visualization? And in order to do that, I think that we could explain a little bit about why visualization works, right? Why visualization is so powerful at communicating data or let us see things in data. Well, it works partially to great extent because our brain, our visual brain, evolved to detect patterns in the world, right? If I show you a bunch of rectangles, all of them having the exact same size, shape, color, etc., your brain, without thinking, already will know that that's a bunch of rectangles that have exactly the same size. But then if I change any feature of those rectangles, the size, the color, the shape, etc., your brain will immediately detect that as well. Because our visual brain evolved to detect patterns and also the departures, the exceptions to those patterns. That's a very powerful, it's a very simple idea, but it's also a very powerful one. And it lies at the core of what we do when we create visualizations. We create graphics that are intended to reveal patterns in the data, but also to reveal the exceptions to those patterns and trends in the data. Now, this is not a novel idea. It appears even in books that are widely considered foundational in the history of visualization, such as, for example, John Tukey's exploratory data analysis. Tukey was a very famous statistician. He wrote about many different topics related to statistics. One of them was visualization. Tukey made the point in this book and also in other writings that the greatest value of a visualization, of a picture, as the quote says, is that it can let us see what we cannot normally see. And that is the power of visualization. The way that I usually describe visualization in talks and in books is that I envision a visualization in a similar way that I envision the pair of glasses that I'm wearing right now. If I take them off, I don't see your faces. If I put them on, I see your faces. So in some case, the glasses work as a tool that sharpens my vision, that lets me see things that I cannot normally see. It is a tool that works as an interface between myself and the world out there. This can also lead us to identify, situations in which a visualization is not needed, right? Maybe just a table is what we need. So what do we need a table versus when do we need a visualization? Well, we need a numerical table when the purpose of whatever it is that we are designing is that readers are able to see individual values, right? If we want to have a display in which people are able to locate a specific data points, a table, nothing beats a table, right? For example, this one, people can go to the row, they can go to the column and identify every single value. This is actually the data set behind Ed Hawkins's graphic of climate change that I showed you before, right? So if you want people to see the temperature that corresponds to 1887, we can just design a table. So when what matters most to us is the individual values, right? The detail of all the data in all its glory, nothing beats a table. But when we care more about, not so much about the individual values, but the overall picture of the data and the patterns and trends in the data, then either the hockey stick chart or the warming stripes is a much better representation of the data. Both of them are powerful. The table and the graphic, both of them may be useful in different occasions, in different situations. Again, if we want to see each individual value, this is more useful. If we want to see patterns and trends in the data, then the visualization is much better. That is what visualization is for, to reveal patterns, trends in data that we cannot normally see, or departures, right? That's a departure. It has a huge spike in global temperatures in the data. That is what visualization is for. Now, visualization, as I said before, is based on the idea of encoding information, right? We begin with a bunch of numbers, we choose certain objects to represent those numbers, and then we vary certain properties and certain attributes of those objects according to the data that we are representing, right? For example, a bar graph uses height or length to represent data, A heat map, this is called a heat map, uses variations of shade of color to represent the data. A line graph uses the position of little dots that later are connected with a line to represent the data. We call that the encodings or the channels, depending on what the type of feature that we are talking, that represent the data, right? Now, the question is, another question that we designers of visualization for communication ask ourselves on a regular basis is, how should I visualize my data? Meaning, how do I choose between a bar graph and a line graph and a map and so on and so forth? Well, I devote weeks of class to explain techniques that can be used to make choices, but I'm going to give you a couple of tips of how we people usually do it. First of all, there are many tools out there that people are using nowadays to guide our choices. These are just two of the ones that I usually recommend students to consult. This is the data visualization catalog, and this is called the visual vocabulary, which was designed by the graphics department of the Financial Times, which is a business newspaper based in the UK. And what the poster does is to classify, to sort the most common types of visualizations according to the purpose that they usually help fulfill. So the Financial Times uses this poster. I say it's a poster because they printed it out, they framed it, and they have it displayed on the walls of the newsroom at the Financial Times, at the newspaper, because they use it to have conversations about their stories. Whenever they are designing a story, a data-driven story, the people who are collaborating to write and to visualize that story, they stand next to this poster and they have a discussion. Okay, what is it that we are trying to show? Oh, okay, we are doing a story about the stock market and how this particular company is performing in the stock market, and we are going to show that performance over time. Therefore, over time, we go to the change over time column, and then we take a look at which graphics we can use. We can try several ones of them, and then we make a choice and we design the graphic, right? So all these chart choosing tools are actually quite useful, particularly for beginners, right? For people who are not familiar yet with the language of visualization. But people who already have a little bit of experience in visualization, what we usually do is to reason about our choices, right? To sort of like think about what the purpose of the visualization is. And according to that, we already know which path to take in order to encode our data. Let me show you just an example. Years ago, I did a workshop for one of the branches of the European Union in Europe called the European Court of Auditors. And whenever I do workshops for clients, I ask people to send me examples of their visualizations so I can gently critique them, give some advice and some recommendations. They sent me this graphic. As you can see, it's the traditional pie chart. And what this pie chart is showing is the total of migrants, immigrants who arrived to Greece, to the country, in 2016, the total of migrants, where they came from. Each one of these portions, each one of the portions of the pie chart represents the percentage of migrants who arrived to Greece from different countries. So even if you don't read the numbers around the pie chart, probably you're already identifying, you're already seeing that half of these migrants came from Syria, and then the other half of migrants came from other countries. And this is actually the purpose of the graphic. When the graphic was designed, I asked its designer saying, was this your purpose? And they say, yes, it was our purpose. And I said, well, then it's fine. I mean, I clearly see half versus half. My only recommendation in this case, I said, would be to color Syria with one color and then all the other countries with the same color, just to emphasize that half versus half message that you want to convey. But then I said, let's transform this very simple graphic into a thinking exercise. Just for the sake of argument, let's suppose that your purpose when designing this graphic is not to show half versus half. Let's suppose that your purpose is that people, your readers, are able to compare these segments without reading the numbers, being able to sort of like estimate more or less the size of this segment versus the size of this segment, the size of this segment versus the size of that segment. Well, we have some evidence to show that pie charts are not great for comparison. If you really want to compare these portions without reading the numbers, you need to sort of like squint, use your fingers, and then put your fingers around the pie chart in order to compare one segment to another. That's a good sign that if the purpose of the graphic is comparison, then the pie chart is not the right choice. Maybe other types of graphics might be better. Maybe a simple bar graph is going to be better for comparison. And then for the sake of argument only, I said, let's suppose that the purpose of your graphic is neither to show the total and half versus half, nor to compare these countries to each other. Let's suppose that the purpose is to show where these countries are, because not everybody knows where Pakistan is or Iraq is, particularly in relationship to Greece, how close or how far these countries are from Greece. Well, to show that, obviously, you will need a map, right? So based on that very simple discussion exercise, I designed three very simple graphics to illustrate this reasoning process, which consists of that whenever I design anything myself, I usually don't begin by designing anything. I usually begin by listing what I want to show or what I want people to be able to see or be able to do with my graphic. Do I want them to see parts of a whole and half versus half? Then the pie chart might be a good solution. Do I want them to be able to compare the countries to each other without reading the numbers? Then the bar graph works quite well for that. You can immediately see that Afghanistan is around 1/2 of Syria, that Iraq is around 2/3 of Afghanistan, that Pakistan is around 1/3 of Iraq. You can notice those patterns even if you don't read the numbers. And then if the map is good to show where the countries are. This little exercise is also something that I sometimes use to illustrate one of the most common mistakes that people make when they begin working in visualization, which is to work in autopilot. For many years, I have observed that if I give a group of people, particularly beginners, a data set in which all the data adds up to 100%, and I ask them, design a graphic with these numbers, they will default mostly to the pie chart. Why? Because everything adds up to 100%. But that is not a good reason to design a pie chart. Maybe the purpose is completely different. And also, if I give people in workshops or classes, a data set that contains a geographic variable, such as countries, counties, states, or whatever they are, and I ask them out of the blue, design a graphic with this data, they will design a map. Well, a map is great sometimes, but it might not be great other times. It all depends on what we want to show. Neither of these graphics is wrong or right. Neither of this graphic is better or worse. They are only better or worse depending on what we want to show. So that's the way that we think about it. Another consideration that we also make in the world of news, in the world of journalism, etc., is what I mentioned before when talking about the cone of uncertainty. Should I just show the data, or should I also explain either the data or the graphic or both, right? Any visualization is made of different layers, right? One of the layers is called the scaffolding layer, which is where we put all the axes and legends. Then on top of that, we put the content, which is the encodings, the way that we represent the data. But then on top of that, we can put another layer that in visualization we call the annotation layer. The annotation layer is essentially all the text that we can put on top of a graphic that may help people understand better what that graphic is about, or notice certain features of the data that shouldn't go unnoticed. Some people who work in visualization for the news will tell you that the annotation layer is actually the most important thing that we do. That quote over there comes from an interview with John Bourne Murdoch, who is one of the data journalists who works at the Financial Times. And he says explicitly that in that interview, he says that at the graphics department, the data and graphics department of Financial Times, they think that the most valuable thing that they do is not the visualizations per se. The visualizations are valuable, obviously, but they only acquire their full value when they add that annotation layer, right? The little piece of text that signals what you need to pay attention to, the title that tells you what the graphic is about, the little notes here and there that highlight the highest value, the lowest value, and that they might explain what is going on in those areas. That's the annotation layer, which is an essential component in visualization for communication. Because imagine a graphic like this with no annotations. People will need to pay a lot of attention to the graphic in order to understand what's going on. The annotation layer may provide entry points to the data, little pointers that people should pay attention to before reading the rest of the graphic. Now, the annotation layer doesn't need to be written. It can also be spoken. right? Some people actually are experts at becoming the annotation layer to their graphics. The most famous one is Hans Rosling. Hans Rosling, probably some of you know about him, was a professor of international health in Sweden, who sadly passed a number of years ago, and who, in my opinion, is one of the most important figures in the history of visualization. He helped popularize data visualization in many talks that he gave throughout the years. He was someone who was capable of transforming himself into part of the visualizations that he was presenting. If you have never watched a talk by Rosling, you can go to his website, gapminder.org. That website collects most of the talks that he gave throughout the years. And notice, when you do that, notice his presentation style. He sort of like merged himself with the visualizations that he presented. Just to give you an idea, this is a snippet. It's a short video clip of one of those talks. It's a short piece of a documentary that he made for the BBC in the United Kingdom a while ago, called The Joy of Stats. In that particular scene of the video, Rosling appears on the scene and he says, I'm going to talk to you about the world. But before I show you anything, be aware, I'm going to show you a graphic that has a vertical axis that shows life expectancy. It will also have a horizontal graphic that shows average wealth of people in that country. So that means that if your country is down there, your country on average is sick and poor. If your country is up here, it means that on average, your country is rich and healthy. So let's see what the world looked like in 1810. In 1810, most countries will be down there. Let's make them appear. Each dot is a country. The color of the country corresponds to the continent that it belongs to. And then, as you can see, there's blue, red. The size of the bubble corresponds to the population of that country in that particular year. And as you can see, in the past, most countries are on the bottom left corner, meaning that they tend to be on average poor, and the life expectancies tend to be quite low, with some exceptions such as the United Kingdom and the Netherlands. This is what he's saying during the talk. But if we animate the world, if we start moving towards the present, you will notice that all these bubbles will start moving towards me, and he uses his hands to sort of like replicate the movement. Notice how he's integrating himself with the presentation, using his own body, his voice, and his arms and his hands to sort of like emphasize, right, annotate and explain the graphic. Notice also, going back to the beginning of the presentation, something that he does at the very beginning. He doesn't show anything. First of all, he explains how to read the graphic. Vertical position represents life expectancy. Horizontal position represents wealth. Bubble color represents continent that the country belongs to. Bubble size represents the population of that country. He was explaining to his readers the grammar of that graphic. There's actually a popular book in visualization titled The Grammar of Graphics, right? How graphics are built, right? Why did he do this? Well, he did this, I think, because he knew that a huge portion of his audience probably were not statisticians, computer scientists, or journalists. Most of his audience were going to be regular people, and many of them probably didn't know how to read a scatter plot, this type of graphic. So if we are going to show a scatter plot, because it's the best way to represent this association between quantitative variables, in my opinion, then let's explain how to read it first, and then let's show the data. As I mentioned before, that is a great solution, I think, or that's a great strategy, because you are explaining how to read this graphic in particular, providing some information about the graphic through your words, but at the same time, you're doing something else. You are educating the public. You are expanding the public's understanding in general of any type of a scatter plot, You're increasing literacy. Another question that we ask ourselves, and that would encourage everyone also to pay attention to, is, am I paying enough attention to the visual design? So sort of like the aesthetic aspects and organizational aspects of the visualization. Sometimes, unfortunately, I feel that particularly people who come from STEM fields, mathematics, statistics, the sciences, with many exceptions, obviously, but many of them pay enough attention to the importance of good design, or good layout, good color, good composition, and so on and so forth. Let me show you just a quick example. All right. And this is not a bad example by any means. It's just a traditional scientific poster. It was designed by students at the University of Miami, postdoctoral students and doctoral students from the University of Miami who attended one of my workshops. And as I mentioned before, whenever I do a workshop, I ask people to send me samples of their work so I can sort of like gently critique it, give some advice here and there. And the point that I made to these students was, well, the poster is not bad at all. I mean, I can read it, it's readable, right? But from the point of view of design, of visual design, I can see certain areas that you could pay attention to in order to improve it. For example, you don't really need all those background boxes that you're putting everywhere, right? Those gray boxes behind every single section. All that they are doing is to make your graphic look cluttered, right? Your poster look cluttered. That diagram in the middle, the triangular diagram that you have there in the middle, I joked with the students saying that as a reader, I don't like to be able to tell what software tool was used to design anything. And I can tell that that was designed with PowerPoint. And I don't like to notice that. I want to notice that something was designed by a human being, not by a computer. I made many other comments, such as, for example, on the map that you can see on the upper right corner, I pointed out, well, that's called the rainbow color palette. That's not a great idea. The rainbow color palette has many problems. Just one of them is that it's not colorblind safe. People who have different types of color blindness, we have a very hard time understanding those colors. This is just an aside. There are tools that let you simulate color blindness. I have actually one installed in my computer called a color oracle, right? You can turn it on and it will simulate on your screen what a graphic looks like to people who have different types of color blindness. As you can see, this graphic looks terrible. The rainbow color palette is also not good for other reasons that researchers have studied. But another point that I made to the students is, do you really need this amount of detail on the scale? And no, you don't. You don't need this amount of detail because nobody is able to locate that specific color on the map or this specific color on the map. The purpose of a map like this is not sort of like show the data with a lot of accuracy, is to give us an overall impression of the data. Therefore, you don't need to have a scale that is that detailed. Why is that scale that detailed? Probably is because that's what the software tool that was used to generate that map, which was probably Python, the programming language, gave you when you designed the graphic, right? But you need to manipulate that because that detail is completely unnecessary. Or this chart that you have over here, which is, you know, gigantic, right? And it doesn't need to be that big because it's only 2 points, 2 data points, right? And it's a little bit too big, too large for the amount of information that it provides. So whenever I'm thinking about design, right, after I have visualized something, the way that I think about design is in terms of editing, right? Editing in the sense of what can I take out that is not needed and what can I bring in that is needed? So in a case like this, what I can take out is everything that I have just mentioned: the background boxes, the unneeded detail on the scale of the map, the graphic, the big bar graph there that doesn't need to be that big, can be made much smaller and perhaps rotated and made horizontal. Those things that I can take out. But I also think about what can I add to the design? And this particular poster and many others that I have seen throughout the years could benefit from thinking a little bit about visual hierarchy, which is a key concept in visual design, right? Take a look at the left-hand side, right? That column over there on the left-hand side, introduction, significance, and specific aims. As a reader, I don't want to read that. It looks like too much text. It all looks gray, all the same. There's no variation. There's no visual hierarchy. It's just a bunch of text that looks like has been copied and pasted from Word directly into the design. That needs a little bit of polishing. For example, we could think about introducing better visual hierarchy on the display, right? Increasing the size of the titles, changing the color of the titles, introducing a little bit of a color variation on the text, increasing the space between things, increasing the amount of white space, in margins in between the objects. So I did a quick makeover in my computer of that poster just to demonstrate all these ideas, right? I say, you know, That poster is not bad by any means, but if we introduce a few changes here and there, the result will be a poster that, including or having the exact same amount of information as the original one, it looks a little bit lighter on the eyes, right? It looks a little bit more inviting, right? It looks a little bit friendlier, right? This to me looks a little bit scary. Oh, there's too much to look at. But here, I don't know, it feels a little bit friendlier to me in order to be, and that's the effect that we want to create on readers. This is the reason why I said before that design is so important sometimes. Paying attention to hierarchy, typography, color, those things are incredibly important in the design of visualization. Visualization is not just about encoding data. It's much more than that. It's encoding the data, presenting the data, arranging the data, designing the data, and sometimes even explaining the data. And in some cases, it also consists of thinking about whether we want to use conventional, traditional visualization forms, such as the bar graph, the line graph generated through a computer, or we want to create something a little bit more unique, a little bit more special, like Ed Hawkins did with the warming stripes graphic, right? He wanted to create a powerful image in order to bring people's attention to the data, to the data that he wanted to talk about. So in order to explain what I mean by this, let me talk to you about my friend Jaime Serra. Jaime is a visualization designer, also from Spain. For many years, he was the graphics director of a newspaper called La Vanguardia in Spain. Jaime is someone who is perfectly capable of producing traditional data visualizations like the ones that I do, like the ones that you probably make in your daily work, but he's also a visual artist. And sometimes he creates visualizations that are not intended to be analytical or to be exploratory or even clear. Sometimes he creates visualizations just for the sake of creating a powerful image that could be hung on the walls of an exhibit, like a painting, because he's also a painter. So one day he decided that he wanted to visualize how much coffee he drinks throughout a year, right? Now, if I had to do that myself, I'm not particularly creative. The way that I will do it will be that every day, imagine that this bottle of water was the coffee mug that I use every day to drink coffee, right? I will draw a scale on the coffee mug. I will pour the coffee. I will measure the number of ounces that I'm drinking. Then I will go to R or to Excel and write that number down on the corresponding cell. And then at the end of the year, I will have 365 records of coffee drinking. And then I will transform those numbers into some sort of line graph that will help me see the ups and downs in coffee drinking patterns every day in my daily life. But Jaime said, that's boring. It's not that it's boring, but it's not what I want, right? That's not interesting, visually speaking. So instead of doing that through a computer, he decided to create a physical visualization. What he did was to get 12 large pieces of paper. He folded those pieces of paper repeatedly in order to create, or with the folding of the paper, the image of the page of a calendar, because each one of the resulting quadrants on the page corresponded to a day. And then when he went to drink coffee, what he did was to try to spill a little bit of coffee on the sides of the coffee mug in order that some of the coffee would accumulate at the bottom of the coffee cup. And then he positioned the coffee cup on the quadrant that corresponded to every day, all right, to every single day, in order to leave a stain of coffee on the piece of paper. And the result was a physical visualization of coffee drinking patterns, in which each one of these papers corresponds to a month: January, February, March, and so on and so forth, right? It's not a graphic, obviously, in order to, that is intended to be very precise or to be analytical in that sense. It's a graphic that is intended to sort of like create an emotion. All right. Oh, this is so fun. Let me look at it. This is so interesting, right? Oh, wow, it's so cool. It's so unique, right? It's so unique. And you can still see patterns, even if in a simple hand-drawn graphic such as this one, we can still detect the patterns in the data, right? We can see the months when Jaime was drinking a lot of coffee, or here, the months that when he was probably on vacation. This is the month of December, right? Not drinking coffee at all. When he was taking a break from work, probably not drinking any coffee, or try to stay away from coffee, obviously, because as a journalist, he probably drinks a lot of coffee, because we drink a lot of coffee, right? So we can still get the stories in the data, even through a very simple graphic such as this one. So that will be my message for you, another message for me to for me to deliver to you today, which is sometimes it is appropriate to think beyond what is traditional. Not always, right? I will never design a graphic like this, for instance, if the purpose of the visualization that I'm designing is to display the data very accurately. In that case, I would just use a line graph, right? But if I want to bring attention to something, then maybe I would create something that is more like a drawing, like a painting. And then if I get people interested in the data, then I present the more analytical, the more traditional graphics later on, so people can take a look at them. Now, if you're interested in sort of like expanding your horizons in visualization, innovations in visualization, people who are experimenting with new ways of presenting information, there are many people out there doing that, but one of my favorites is the pudding. The pudding is a publication. It's an online publication put together by an organization called Polygraph. And what it is an online magazine. It's a magazine that publishes stories, journalistic stories, but always driven by data, right? All of them are data driven and usually visualization driven. Most of their stories contain data visualization, and their visualizations are usually very unique for different reasons, either because they have new interaction forms, either because they try to innovate in the way that they present the data, either because they incorporate other channels, not only visions, sometimes they also use sound to present data. It's highly innovative. It's a constant source of inspiration for me. But at the end, or for me and for many other people, but at the end, what really matters in visualization for communication, what we always need to think about, regardless of what we do, is that about what truly matters. And what truly matters is neither ourselves as designers, nor the data that we are presenting or the information that we're visualizing. What really matters, or at least to me matters, is that people actually get it, right? So the whole reason why I work in this business, in the business of communication, in the business of journalism, in the business of science communication and visualization for communication, is that I want to convey information to people. I want people to understand what it is that is going on out there, right? So what matters is whether people actually grasp the ideas that we're trying to communicate to them. And sometimes we can test that. We can actually see whether they actually get it, asking them or conducting actual UX research or UX testing to see whether they actually get the idea or not. This is what truly matters in visualization for communication. Anyway, so that's all that I have for you today. Let me check the time. I think that it seems that I timed it perfectly. It's 10 p.m. over here. So this has been an hour in total. And that means that we have another up to half an hour for conversation, questions. I'm here for you. So you just let me know.
Okay, thank you so much for the fantastic talk. Okay, so many excellent case study and provides a lot of valuable tips on how to make our graphics more appealing, but also more understandable. Okay, two of Professor Cairo's books have been translated and published in Chinese. I'm sure most of you here have read them carefully and would like to ask him some questions. So now, do you have any questions or opinions that you would like to share with Professor Alberto? You can type or turn on the microphone to ask questions directly, okay?
Yeah, actually, I have a
go ahead.
Mm-hmm. So
go ahead. In the meantime, I'm going to export the slides so I can share them with everybody.
Sure.
I'm going to actually put the link. Sorry to interrupt, because otherwise I'm going to forget. I'm super absent-minded. Those are the slides. They are still uploading, so give them a minute. Go ahead, please. Go ahead.
Sure. This is Le Liu from NWPU University. So you mentioned about like the rainbow color map. So I partially agree with you. Like in some instance, like rainbow color map is probably not a very suitable solution for portraying data, especially continuous scalar data, something like that. But like in my personal experience, like when I talk to some domain experts, because like rainbow color map is kind of one of their traditions.
Yeah.
So
they are so used to they are so used to seeing it that they know how to read it, right? Yeah.
Exactly. And sometimes like because they already have those kind of mental patterns to recognize this kind of rainbow color map, even though it has a few problems. And in some specific scenarios, like rainbow color map can definitely show them some kind of significance of their data, like important patterns or differences. So because you have quite a lot of like experience working with domain experts, I would like to ask for your opinions about using rainbow color map, or how to balance like domain experts tradition and their kind of preference with the theoretical consideration of color usage.
Yeah, so that's a very good point, which is that education helps, right? It's like knowing what you're looking at really helps understanding a graphic, and that includes the rainbow color map. The main argument against the rainbow color map is that it's not accessible. That's my main argument. So even if you know how to read it, if you have certain types of color blindness, you cannot read it. You cannot interpret it correctly. So that's the main argument against the color map. Now, if you are not colorblind, right, and you know how to interpret the color, the rainbow color graphic, it can work for you if you're an expert. And one of the main messages of the book that I'm writing right now is actually that if it works, it's good. That's the main message of the book. Because sometimes we don't know why a graphic works, but if it does, then it's a good graphic, right? If it delivers a message that you honestly and ethically are trying to represent, and it represents it correctly, then the graphic is perfect. So I would say if you're talking to an audience of experts and they know how to read that type of graphic, and the rainbow color graphic lets them see particular thresholds in a continuous scale and blah, 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 and they know how to read it, fantastic, go ahead and read it. But remember, I don't visualize for experts. I visualize for the general public. And the general public, we have sort of like, I have observed already that they tend to see artificial thresholds in the rainbow color palette. When they see a change in hue rather than on shade, they try to identify that as some sort of something is going on here. When the actual scale is just sometimes it's completely continuous. There are actually no thresholds in the data, right? So it may be a little bit misleading, but the main argument is the color blindness one. It's simply not a good color palette, particularly if you have a color blindness. And I will argue that until the end of time. We need to consider accessibility. Actually, I didn't mention accessibility during my talk, but it's one of the areas that I'm most interested in at the moment. I'm doing some reading, I'm trying to educate myself, and there are certain very basic things that one of them is to pay attention to color palettes. Another one would be to provide, for example, alternative text to visualization. So whenever we produce a visualization for communication, not just to put the visualization, but also write a description of what the graphic is showing, because obviously the graphic is not machine readable. So people who are visually impaired cannot see our visualization, but their computers can still read the alternative text to them. So those are the types of things that I'm most interested in at the moment. That will be my main argument about it.
All right, thanks for the answer. It helps a lot.
I'm seeing a question from Rebecca there. Yeah.
Yes. With the further development of virtual space, what new opportunities can it bring to information design or data visualization?
Yeah,
Rebecca's question.
Yeah, it's a great question. It's actually one of the areas that we are looking into at the university. We have a couple of professors who specialize in virtual reality, augmented reality. I'm not in these areas yet, just because days only have 24 hours, and I'm already quite busy doing sort of like evangelizing about traditional visualization and teaching people how to read classic graphics and visualizations. That's what I devote my time to, but I'm certainly interested in knowing more, and I see possibilities in there. I am a little bit skeptical, and I still have not found examples to prove me wrong, but I have been proven wrong many times in the past. I will preface that convinced me that virtual reality and augmented reality is really useful for data visualization, right? The examples that I have seen so far tend to be quite messy. difficult to navigate. They tend to be more confusing than not. Seeing yourself in the middle of a graph that you can see sort of like around it makes me feel dizzy. But maybe it's just because those examples that I have seen so far are not well designed. Someone may come up with good practices of visualization design in virtual spaces. We'll see what the future brings. On the other hand, I do think that virtual reality, it has a lot of power to deal with scientific visualization and pictorial visualizations. For example, let's imagine that you do a 3D high-resolution model of a human heart, of a living human heart, and you map that, and you reproduce that in virtual space so you can let doctors or even the general public walk inside the heart and see it from the inside, right? That's an example of a scientific visualization because it transforms real-world data and maps that into a graphical representation in 3D space. So I've seen examples like that. The National Geographic years ago created a 3D experience in which you can navigate through a cave, and it was amazing. So for those types of things, I think that there's a lot of future. So again, I am persuadable. I'm just looking forward to see what people can come up with, what innovations people can create. It's only that I really don't work in innovation. I am usually joke with my colleagues at the university that I really admire people who create new wonderful toys, but I'm much more interested in teaching people the toys that we already have and help them understand those toys a little bit better before we all take the next step.
I absolutely agree with what you just said, but also at the same time, I'm thinking virtual reality might require a new language because right now what we are thinking is to translate what we are using today in terms of design language into the virtual world. Maybe we need a different language in that environment. So
it could be.
But anyway, I believe right before me, there's a related question about machine learning. Juanjuan, if you don't mind, read that question to Alberto.
Oh yeah, that's a question that I cannot answer because my knowledge of machine learning is absolutely minimal. So I can really not answer that question. I'm very sorry. Yeah. Other than saying that, visualization can help, for example, explain what a machine learning algorithm is, which is something that people don't know. So I see a lot of potential in explaining anything that related to science. Yeah. There's a question here about how we can teach non-designer background math students better learn visual communication design skill in the visualization course. As a visualization lecturer, how can we teach the non-designer background? So you are asking how to teach designers math or how to teach mathematicians design? I think that I didn't understand the question from Ling Yun.
Hi, so this is Ling Yun, and we are asking that because in our class we don't only have like computer science students, we also have some like industrial design students or mathematics students. So how do we teach them visual design, something like that?
Yeah. Very good question, Ling Yun. Thank you. The way that I do it, and I don't know whether it's the best way to do it, it's just the way that I do it, through practice and demonstration. The same way that we learn to write is through practice. Or we learn to write by reading, writing, and then getting the writing corrected, right, by a mentor. That's the way that I teach. The way that I structure my classes is that half of my semester, which ended a week ago actually, is all about exercises, lectures, principles of visualization, history of visualization. The second half of the semester in my classes is let's get stuff done. I'm going to give you a project, you work on it, show me the first version, I give you feedback. Go back to the drawing board, change it, come back to me, I give you more feedback, and then more feedback, and then more feedback. And while giving the feedback, I help them sort of like sharpen their design skills, because I don't just tell them, change this font to that, or change that color to that. I actually explain why. And I demonstrate it sometimes. I sometimes open their projects on my screen and I actually change the projects in front of them. Rather than positioning this here, you may want to put it here. You need to line this up here. Don't you notice that it looks better now? When you demonstrate it that way, something clicks, right? It's much easier to do it that way for me, to demonstrate rather than to explain. Because when you explain, the explanation can sound too abstract, right? But when you show it in front of them, then it's like, oh, wow. It's like, again, when we teach writing, I would teach writing the same way. We cannot, and we need to show them tons of examples. That's the other thing. We human beings learn by practicing, but we also learn by copying. But copying not in the sense of plagiarizing, but in the sense of getting inspiration. So I try to expose them to the work of many people. And when they see, for example, that a student is working on a topic, on a graphic about a particular topic or with a particular style, I try to expose our students to the work of people who work around the same style, right? Take a look at what this designer did. Take a look at what the designer did. Don't copy them completely, obviously. You don't want to plagiarize anybody, but you can borrow ideas, right? Take a look at how this person manages typography, the organization of the graphic. So I learn by demonstration, by emulating, by getting inspiration, and then by doing a lot of stuff, and then giving a lot of critique. This is a craft. It's a craft. So it needs to be learned like a craft, like any other craft.
Great.
Now, teaching mathematics to design students, that I cannot answer. That is much harder. Thank you for the question.
I think that from my experience, that if we have some group projects and we assign some computer science background students and also industrial design students, and they work together, well, then I think this is a good way to have new ideas.
New ideas, yeah, just to have conversations in the group. Yeah. That can also help. However, in the line of work that I do, I prefer not to give them group projects at first.
Okay.
Because if I give them group projects at first, there is always going to be someone in the group who is going to work more than the others.
Okay.
And I want all the students to acquire sort of like the same base level of skills. I don't want them to specialize. I want everybody to be able to design maps, graphs, charts, different. And then after that, then I can give them a group project and they can distribute the work a little bit more in a more specialized manner. Yeah, it's different, I guess.
Yes. Great suggestion. Thank you very much.
Okay, thank you for your question. Hello, Albert. Maybe perhaps we missed a question before Rebecca's question. Can you see it? Amazing talk and thank you for sharing.
That's a question about machine learning algorithms that I couldn't answer. Yeah, sorry about that. I'm completely ignorant about machine learning. Yeah, other than understanding conceptually what they are. So
yeah, also the same situation of the last one. Yes.
Yeah, but the last one is actually quite interesting. I already read it. I am always wary of reading your names because I will mispronounce them completely. I'm so sorry about that. Yunwa, I don't know how to pronounce, sorry about that. Well, anyway, that's an excellent question because you ask, when we want to communicate science, I'm going to try to paraphrase, when we want to communicate science to the general public, there is always the danger of oversimplifying things, right? To try to convey the ideas that we want to convey in such a clear manner that we may end up losing a lot of detail that it is needed, right? In the story, we may sacrifice too much detail whenever we present information to people. Do I worry about that? I worry about that all the time. All the time. The answer is so what I think about this problem, I think that it's a huge problem. And it's not easily solvable because there's not really a single recipe that can be applied to every single case. Every single case is different. Now, I can tell you how I do it, right? So I usually equate these to, for example, the discussions that I sometimes have with the students about when we present data. What level of detail do we need to describe, for example, a distribution of data, right? A univariate distribution of data. Well, that can be described, that can be shown every single data point in the distribution, all the dots. Or it can be summarized, for example, in a histogram, or it can be further summarized in a box plot, or it can be further summarized just displaying the median value or the mean value, and that's it, right? So which one of those levels of detail is adequate? the high level of abstraction, just the measure of central tendency, or every single data point in the distribution? There is not a right answer to that question. It all depends on the nature of the information. Some distributions are so condensed and compressed around the measure of central tendency that showing every single detail is a little bit besides the point. It's enough to just show you the median, right? That describes the distribution really well. Whereas other distribution will require to show every single data point or one step in between, right? So the way that I envision science communication is quite similar to that. Whenever I'm trying to translate science for the general public, a conversation needs to happen between the scientists themselves and then the journalist and the designer in order to understand what level of detail do we really need, right? And never try to oversimplify, but also never try to do the opposite, which is to overcomplicate, right? Scientists, we journalists tend to oversimplify and scientists tend to overcomplicate, right? So we need to find a middle ground between the two. I usually try to trust scientists though, so my visualizations tend to be quite detailed, right? I like to create visualizations that are quite detailed. I don't think that I can be blamed for oversimplifying stories, but at the same time, I've also had plenty of conversations like these about what is the middle ground, right? How far we can go without oversimplifying or overcomplicating. I usually refer to quote that is commonly attributed to Albert Einstein when describing science and theories of science, when he said, everything should be made as simple as possible, but not simpler. That's the way that I envision visualization. I try to create visualizations that are as simple as possible, but there is always a threshold that we shouldn't go through, because if we go through, we may lose specific details that are intrinsic to the story that we're trying to tell. This is a discussion, for example, that I had this morning, because just full disclosure, this is the fourth talk that I'm giving today. And I had this discussion in the first talk this morning in which I was talking about the visualization of uncertainty, for example. When I show, for example, a margin of error or a confidence interval in a visualization, I don't always show it. It all depends on, for example, if I'm comparing 2-point estimates, how close they are to each other. In cases like this, if they are very close, then absolutely I show the uncertainty of the data, because the uncertainty is an intrinsic part of the story. The points are so close that we don't know whether the difference between them is statistically significant. Therefore, it's important to show the uncertainty of the data, even if the graphic is to be shown to the general public. But if the points are very far apart, and then the level of uncertainty is not very wide, then if it is a graphic for the general public, I may say, well, maybe showing the uncertainty is a little bit besides the point, right? Just because the difference is so enormous that, you know, then the uncertainty doesn't really overlap between one point and the other. So that's the way that I usually think about it. It's all the product of a conversation that sometimes you can have with yourself, but more often happens with the people who are experts in the areas that you are visualizing about.
Okay, thank you for your answer. Actually, I have a question. I want to ask you about your opinion about narrative in visualization. In the design process, how do you consider visual narrative? That's my question.
So yeah, I didn't address this in the talk, but another consideration that I make whenever I'm designing a visualization is whether I can actually arrange a graphic in the form of a narrative. 1, 2, 3, 4, 5. This happened, then this happened, then this happened, then this happened. If it is a graphic to be shown to the general public, I usually try, but it's not always possible to create a linear narrative with data. But if it is possible, I absolutely do it. And the way that I do it is, this is a technique that I teach my students, is once I understand the data, once I have spoken with the experts and understand what it is that we're trying to communicate, etc., I usually don't begin by drawing anything or visualizing anything. I begin by writing a short paragraph summarizing what messages I want to convey, right? Or what is it the graphic that is, what is the graphic intended to describe? And I write that very long sentence. And then what I do is to split that sentence up into its natural components, right? For example, an example that I usually put is related to a population change, right? A country grows, but then the fertility rate of the country is different or than expected, and then blah, blah, blah. So I write that sentence, and then each one of the little portions of the original sentence may become the titles of each one of the sections of the graphic. And then I illustrate those points that I'm making with an appropriate visualization that makes that point, that supports whose data support the message that I said before. So I usually begin by writing in many cases, not by visualizing anything.
Okay, if there are any questions, you can email to Alberto also. Okay.
Well, you have the slides in there. My contact info is there, and you can download the slides, use them at will. Again, thank you so much for having me. It's always a pleasure.
Okay, thanks again to Professor Alberto for this great speech, and thanks to the audience for the high quality questions. Okay, next I will forecast the 14th lecture. Okay, let's share the screen. Our next speaker is Professor Han-Wei Shen from Ohio State University. His topic is machine learning for scientific visualization. The presentation will take place on April 7th from 7 o'clock p.m. to 8:30 p.m. Okay, let's look forward to next academic exchange. Thank you, everyone. See you in 2 weeks. Okay, thanks a lot. Bye-bye.
Bye, thank you. Have a good day. Bye.
Yeah, you too. Good evening. Bye.
Bye, everyone.